Hi folks, this is Dan. I'm here to give you a quick tour of the Foenix IDE. The Foenix IDE was built to emulate the C256 Foenix computer that we are currently building. So the IDE has been built in C# and it's based on the NU256 emulator that was emulating the 65816 microprocessor. So the IDE here is able to emulate the processor, but it's also aware of other devices such as Vicky and Beatrix and Gavin that the actual hardware has. So when you're trying to develop a new game or a new application for the C256, having an emulator like this is going to be quite handy, especially when you want to find a bug or a flaw in your program. The application is also able to emulate interrupts, and we'll get into that in a few minutes. So I already have a kernel loaded here. It's a basic kernel for the application for the new hardware. So the way you would learn a kernel is by opening a hex file. So what you can see is I've built several files over time. So the kernel is here. So I'm going to load that. And what that does is essentially a reset on the machine. So you can step through and you can see the operations are getting listed here. You can see the stack is getting populated as we do push A, push P, etc. And you can see at the bottom here the next command that will be executed, right? So you can step through or you can run. So when you run, you'll see that things start to go really fast. The CPU goes to close to 2 megahertz. So it's able to execute things not in real time, but it's getting pretty close. So when I was saying we were able to handle interrupts, the keyboard has been one of those things that generate interrupts. So we're able to type commands like this. So get date, get time, clear screen, right? So all this works exactly like it would on the machine. Another thing that you can do is you can see in the memory window, things get changed here. So Vicky is the graphics processing unit, for lack of other terms. And you can actually go see in the video memory, and you can see everything that gets displayed. So right now they're all zeros. But as we play with the other master control registers, you'll see that we can go in and flip a bit somewhere or add a byte, and then it changes how things get rendered. So I'm going to stop the processor here because my CPU is still working very hard. So the other thing that you can see in the debug window is that we're showing all the registers of the CPU for each instruction. So as the instructions get run, the registers get updated. All right. So this is quite handy because now you can really see what's going on in the processor. Another thing that you can do is you can reset the machine. So I can reset. Either I only want to restart the machine, or I can reset in debug mode. Right. So this is allowing us to, again, start the program. I can set a breakpoint to actually, here, let's do a breakpoint here. That's going to step over to after this branch not equal. So we can do this, just a simple click. And now it's executed all the operations. So it was incrementing the X register to 400 in hexadecimal. So now we're at the next instruction, and then we can step again. Okay. So obviously the yellow line means it's a breakpoint. So another thing I could have done, so if I add this breakpoint and I do a reset and run, right? So it's just going to rerun everything to this state here. So the breakpoints persist over the resets. Okay. All right. Another thing that you can do is we have a memory button. So if you want to see the memory at FF00, you can click on this memory button and the memory window automatically changes. Okay. Another thing you can do here in the master control register is you can change to text mode. So obviously there's no columns or no lines set in memory right now. So Vicky is saying, well, I don't know what to do with this. Okay. So as I execute more code and Vicky gets initialized, you will see that more things get put on the screen, right? We're almost there, right? So now the display is reset, and now I'm going to start drawing text to it. Anyway, there you go. That's what it looks like. Another interesting capability is gamma. So when we're in the DVI mode, the gamma gets displayed, or the colors get corrected by gamma correction so that they appear brighter. Another mode that we can play with is the overlay, right? So the overlay uses the background color that's being set in Wiki at the address AF0005 to AF007, so that's purple. All right, so in overlay mode, I can see the background. Okay, if I disable text, you see no text. If I disable video, then of course video is now gone, right? So there's a reason to disable video in the C256 is to allow the CPU to use the full bandwidth of the machine. Okay. All right. Another thing you can do at this stage is you could save your project. So when you save your project, you're saving your breakpoints and any resources that you have loaded. So we haven't loaded any resource yet, so it's not really that useful. Another thing that you can do here is you can load images. You can browse for files. So I have a few images I've been playing with. So let's try to find one of these. So there's tiles that I've been playing with, so you can see what they look like here. You can load your tiles, you can set the destination address, which tile layer it is for, and which lookup table to use. So when you store that, you will get a transfer successful. So now if I go to address B00 in memory, you'll see that there's now content in here, right? And you can use page down in this window to go quicker. All right. So if you try to load, one of the advantages the IDE has is that if you try to load another image or the same image in an address range that would overlap. So let's say I try to put it there and say I didn't know, right? That's not a valid address space, by the way. But so if I try to do that, the IDE will first prompt me that, well, you're trying to load an image that overlaps another one, and do you want to do it anyway? So I'll say no. So I can load the bitmaps again at B4 like this, tile 1 store, and this is fine. Another thing we can do here is start playing with the tile editor. So when we're in tile editor mode, we get a new window, and now I can see my tiles and I can have a way to edit them. So now layer 0 is enabled, layer 1 is enabled because I just loaded them and they're the same, and layer 2 and 3 are not enabled because there's nothing in them. The display here shows you the address shown here. So if you're loading B0, like we do in this case, you'll still see an image. So that's why, even though the layers don't actually contain anything, you're seeing this. Another neat capability is that you can disable the layer. So let's see what happens when this happens, right? So all the bytes go away, right? So one thing I like to do is I can just set, a little tile set like this, trying to go quickly, and right, and then I'm going to pick the next tile, and I just lay the tiles down like this. So I've tried to make it so the tiles are, they're not pretty or anything. I'm not that great at that stuff, but it's making the layout pretty easy. I made a mistake here, so I'll correct that. There you go. So now, laying your tiles down, I mean, this is not how you would, this is not a very pretty game at this stage, but anyway, this is making the whole laying of tiles a lot easier. All right, so when you exit the tile layer, right, you go back to text mode. Well, now you can overlay your tiles here, right? And maybe I'll disable the text. There you go. So now that's how your display would look. I have no sprites enabled and I have no bitmap, so that's something else we can do, maybe in a separate video. What else? We have an uploader, so I have a machine connected here, so we can connect to an actual C256 and pick a file. So the files that we send are typically bins, so they're compiled from assembly. Oh, I don't have a file here. So what you would do is you would find a location, actually, which I'm not finding right now, for something you've compiled. There, the kernel, right? So you pick your file and you say, where do you want to upload it to? So typically would be at address 18.0, connect, and then send the binary. So I'm not going to do that right now, but that's the feature there is to upload files or to upload directly from the emulator memory into the C256, or another option is to read data from the C256. Then you can say what address you want to start from and how big of a block you would like to download, and then you can fetch. All right. What else? Yeah, often also when you're doing programming and you have another window for your compiler and everything, the CPU window sometimes goes into the background. So this window menu is bringing them back to the forefront. Reset I've discussed. About just shows you the version of the software, so that if you need to raise an issue about the software, please give us the version number. All right, so this is the quick tour. There's more to talk about, especially when we start talking about interrupts and handling of the starter frame, but I'll do this in another video. Okay, have a good night.